to reference it later, show your friends, whoever. It's better with audio. I'm sure the audio on. So now we'll stop at each one, talk about each one. So squash and stretch, number one. Even if an object doesn't have, or you don't think it should have, some squash and stretch, you'll be surprised at how much just adding this into your scene can really add to that. Even like a let's say a bowling ball going really slow wouldn't have a whole lot of squash and stretch, but sometimes we will add a little bit of movement to it just so we do get that movement of exaggeration, basically. Even people, even though you wouldn't like squash a person down, you could still have them squat and then stretch out in order to do that. That's the same kind of thing. That's the same ability of squashing and stretching that kind of emphasizes what's happening there. Okay. On our second assignment, we're doing a bouncing ball. We'll really use this squash and stretch on that bouncing ball assignment. The second one we won't, or the third one we won't, just because that one we just won't want to have time for it. Okay, but that's something obviously you could add to it. Anticipation, I'm actually going to jump over to a great resource called Wikipedia. Suppose animation wiki. Here's a great picture for anticipation. You know, the pitcher doesn't just throw the ball. He's not standing with the ball and it just like leaps from his hand or he pushes it forward. We get a little bit of a hint of what's going to happen beforehand. Okay, so he's standing there at the mound and then he winds up and then he throws it, right? That wind up is important to the story. It's important for us to understand what's even happening in that. Because if we don't see that, we lose some of that stuff. When we're animating something, we only have a few frames. Sometimes we only have maybe 10 frames, okay? And in that time, you have to get that action to come across. So by having this anticipation there, having a before action really helps understand what's happening there, okay? So a bouncing ball, there we go. A bouncing ball right here that's about to just start moving this way, he gets a lot more storytelling, a lot more believability if there's a reason for him to propel that way. So what he should do is squash down and aim towards that direction, okay? So we should be in, you know, something like that, letting us know that he's about to squash, and then the next one, look at that stretch, he's stretching in that direction, okay? So that anticipation, that before action, is important for us to understand what's going on because we can miss it. We can lose sight of it and kind of say, well, something's off here if we don't have that anticipation. Okay? Staging is super important. We'll use the same bouncing ball example. From that angle, you can see the ball is squashing and stretching, and it looks wonderful. Okay? There's the ground. Here's our ball. And now it's going this way, so it's stretching like that, and then it's coming over here, and it's hitting, and it's doing all this stuff this way, from above. You can't see what's happening. You have no idea what the ball is doing. Is it making contact with the floor? So we have to create good angles for our animation to work. So typically for something like this, we go from the side view just to start. That way we can see there's the ground. We can see the ball coming up here. We can see it there. We can see it there. We can see it kind of flatten out and then do this whole process again. It's easy for us to see that motion because of the angle we're at, okay? As we're doing things, some things are going to be for the classroom, for the grade, in order for me to see what's happening and for me to kind of critique how the arches are going. But when we create something for a demo reel or a portfolio, we want to create the best camera angle that we can do. Typically, people like to go with crazy, now that we can set keyframes, they go crazy with camera angles, and they have that camera zipping around the ball so fast you can't even see what's happening. All right? As you watch movies, pay attention to the camera angles. Pay attention to the cuts inside of a movie. You'll be surprised at how often there's a camera cut, how very few frames are actually on any one scene, especially like Transformers or any of those action movies. Okay? But staging is important to make sure that everything is kind of lined up correctly. The last one, oops, let's go back to number 4. Straight ahead or pose to pose. This refers to 2 different ways to animate stuff. Okay? If you think of an animation, it's just frames, right? That's all it is. So when we animate something and we do straight ahead, straight ahead. Doesn't sound right. We would say, okay, here's frame 1, the ball's here. Frame 2, the ball's there. Frame 3, the ball's here. Frame 4, the ball's there, and so on, okay? One at a time, straight ahead. When we're doing poses, we're creating the poses for it. And then we can go back in here. Let's say this is 1, this is 6, and this is 12. We're going ahead and doing the poses, then we can come in here in between and start to add these other ones in here. We're creating these little individual poses. When we do a pose, we're creating strong poses and then blending between them. It's very easy to do pose to pose because we can kind of set up and say he should be here at this frame, here at this frame, and here at this frame. If we do straight ahead, we might move these a little bit too slow, and then if we need to fix them, we have to go back and fix all of those, okay? So everything we're doing in here that I can think of at the moment, we're doing pose to pose, all right? But some things you may want to do straight ahead depending on what kind of animator you are. When they do animation at Pixar, they do, the master animator will come through and he sets up the poses. He goes in there and he caresses them and makes sure that they're exactly the way they should be, they're timed out the way they should be, and then the junior animator will come along and he'll set up all these minor poses, okay? Here's an example of some of the poses that you would see. This one. So this is the animator for Horton Hears a Who. Okay, this specific scene, this guy was animating. In order for you to animate a scene, it is incredibly helpful to have some sort of reference. You don't have reference for what this guy should be doing, so he has to make it. So a lot of times the animators have cameras. They set up a camera, they act the scene out, and then, excuse me, and then they go and they animate that scene. So up here you're going to see on the top right, these are the poses that the character is in. Down here, this is a bit smoother version, and then this is like the final render, okay? Just so you can see what those are going to look like, and that's obviously him acting it out.
And then you get the feeling that maybe that thing watching you is a giant elephant.
And you see how like bumpy it is, okay? Those are poses. He's just showing, I'm here, I'm here, I'm here, I'm doing all this stuff. And then in this stage, he's saying, those are good, now let me add those in-betweens. Let me add how these poses are transitioning one from the other. If we have a character jumping, we have one pose, we're just going to do it very easily. One pose, he's kind of squashed down and he's squatting. The next pose, he's jumping up. We have to figure out how those things transition from one to the other, okay? So that's what those in-betweens are. And that's just, like I said, a way to animate. I like pose to pose. Some people will do straight ahead animation. We're again going to jump to Wikipedia. They have a good example of this too. Make sure that's the right one. That was follow through and overlapping actions. So in this one here, well, let's jump back to the baseball one. There we go. Okay, so in this one, we have more than just the action of He throws the ball, and then the action doesn't just stop there. Okay? He throws the ball, and his arm goes down, and his foot goes up. Those are the overlapping actions. Those are the follow-through that's going on with it. All right? When we do an animation, it's very easy to get focused on just what our animation is. We animate a ball bouncing. It bounces. But what else is happening to the rest of the scene? Maybe he hits something and something else gets knocked down. Maybe he has a tail and that tail is kind of wobbling too. Maybe anything is happening to that thing. The more stuff we add to this, the easier it's going to be. Or the more believable it's going to be. Looking at this horse here, I don't know if I can zoom in, I can. Sometimes we get focused on just like the basic mechanics. What is the body doing? What are the feet doing? We don't focus on what is the tail doing? What is the hair doing? What's the rider doing that's on there? What's the, whatever that thing is? The reins. What are the reins doing? Okay? So we don't focus on some of those things sometimes, but adding those things adds another level of realism to it. Now when we're doing something like the pose to pose, we focus on those major things first, and then we come back in afterwards and then we add stuff like the tail flapping and the reins bouncing and his ears doing whatever. Okay? Oops. There you go. There's their example too. So you follow through an overlapping horses thing. All right, slow in and out is a way that we animate our stuff. I'm going to show it in Maya. It's going to be easier to see. Right there. Okay. Essentially, when we create some sort of animation, we don't want it to go, boom, right to that spot. Okay? We want to have some sort of gradation, some sort of sloping that gets us into it. So I'm going to use this sphere, and I'm going to close these windows. There we go. All right, so I'm just going to set a keyframe here. Set a keyframe there. Oscillate. Okay. So right now I'm going to set this to straight ahead, okay, or straight. Okay, so there's no slow in, slow out. It's just going to go from point A to point B and back again. Let me slow it down. There we go. There we go. So we're moving at a constant speed both ways. It moves from negative 80 to 80 to negative 80 to 80. It's very, very jerky. When we talk about slow in and slow out, the actor or the object should go slowly into positions and come slowly out of it. Now there's exceptions to that. They're not saying for every single thing use slow in and slow out. But be aware of when you want to, you should use it because it needs it. Okay? Some people just forget it and they keep everything like this, or they don't do any of it. Okay? They just keep everything slow in and slow out. So in this case, I'm slowing down my keyframes at the beginning, and I'm slowing down my keyframes at the end. So you can tell just by clicking one button, this animation looks 10 times better because we have that slowness going in, that slowness coming out. We have to understand when we animate something, what is the physics behind it? Why is this object doing what it's doing, and how can we fake that a little bit more? So what's happening here, let me stop it. At the beginning of this, we're imagining that something happened, okay? And for whatever reason, the ball is dropping and it's rotating around. So as it's here and it starts to drop, gravity is pulling it down, it's going to start picking up speed, okay? So it's going to go slow at the start and it'll pick up speed, pick up speed, pick up speed. Because it's on this little loop here though, once it hits this spot, it's going to start slowing down. So as we look at this, and I hit play, or scrub it, right here, it's at basically the bottom of the graph. It starts to slow down because now it's working against gravity, so it has to slow down, right? If that graph is straight and we have no slow in, no slow out, it ignores all gravity, okay? So if we're animating this in outer space, that might be a perfect way to do it, okay? Now some spots where we don't want to have slow in or slow out might be if he is supposed to hit something, okay? If he's supposed to hit the ground and come out of that, that might not be where we want a slow in or slow out. We'll get to that though. Arcs. Arcs is another important one. When we have the baseball player and he's winding up and he's throwing the pitch, notice how my arm doesn't go from here to here, right? There's an arch. There's a roundness that happens to it. That is in everything that gets animated. The only thing that doesn't would be something maybe robotic, okay, or something, you know, going on a straight plane. But typically for organic movements, we have arches to it, or we have an arc to it. So there's some sort of rounding, some sort of offset there. When you do a walk cycle, you don't walk from here, your foot comes up, and then it goes back down. There's a circle, there's a cycle that happens to that to get it to move the way it should move. And then secondary action is exactly what they just showed right there. Timing, obviously, timing is important too. The distance we're setting keyframes apart, when things happen, is important. Okay, this one is really, I pair it with anticipation, okay? When we have our character and he's anticipating pulling the ball back, having that exaggeration of that extra throw and that extra kick up with his leg and his arms really far out, exaggerating it helps prove that movement too. If we don't exaggerate, sometimes those movements can get lost, especially when we're doing something like a bouncing ball where we literally have like 3 frames of animation of that ball being squashed or stretched. We have to kind of exaggerate that stretching or squashing in order for the viewer to see it, because it happens, I'm saying 3 frames. If we're going at 30 frames a second, that's only like that much of a whole second, okay? So we have to exaggerate stuff so people can see it. Again, remember this was like Disney created these rules. The solid drawing part of this still applies. Even though we're not drawing anything, we're using 3D, you have to be able to see that action. You have to be able to see the animation, okay? And going back to the staging part where we had the ball and it was hard to see it from that angle, it's also very easy to get lost in an animation when the background, even though we're going from the side view, the background is just too busy. There's just too much stuff going on. Or the lighting isn't correct. You know, we really have to make our actor shine. We really have to make him stand out. If we had a red ball on a red background, you can't see him, right? So we have to make sure that the colors are nice, the lighting is nice, everything kind of works. And going into the last one, appeal, just how much does that animation actually appealing? You know, you could follow all these rules and still fall apart. Okay. Now there's also other ones out there. These are just the starting ones, so we'll just go with those to start with. Okay. I'll show a couple more things of this just so you can see it.
And you might want to zip up the pouch for this next part. All right, fat boy, you want some of that?
What? I'd do it myself, but being a lady, I prefer not to get my hands dirty.
I'll just be quiet now. You know, sometimes you get too tired to sleep. You get past the point of no return. Kind of feel like that, right? But anyway, I'll shut up. Not quite. How about now? Is this better?
Yeah, sort of.
Come in there.
Kinda losing you. Whoa! Oh!
Mr. Mayor, are you seriously proposing that we spend the Who Centennial underground like worms? Mayor!
I found you!
So you have to have a lot of humility when you become an animator. You just go in the room and start doing that. All right, so those are the 12 principles of animation. As we start getting into our own animation, start creating stuff, always look at that list. Have that list handy. Once you do your first one, you may not have all of those, but you try to encapsulate as many of those as you can. When we do the second one, we should have a lot more. As you get further and further in those, you'll start incorporating a lot more of these into your scene, okay? That's that. All right, so you're going to go to the Start menu and you're going to open up Computer. By now, you should know on these computers, the C drive, the desktop, you cannot save any of your work to, okay? We have to save everything to the D drive. You save anything elsewhere, when the computer reboots, it's gone, all right? So we're going to go into the D drive and we're going to create a new folder. And you're going to call that folder your last name _ F14. That's easier for you to see if it's that big. There we go. Bang. Okay. So your last name _ F14. Inside that folder, you're going to make a new folder called 2540. 2540. Inside 2540, you're going to create two folders. One's called Work, and one's called Source. All right, so we deleted our preferences. We've opened up Maya. We're going to wait for all those pop-ups to come. The pop-ups inside here that first come up, most of you probably don't need. The reason it's asking to copy is because you have a 2014 folder there. Oh. So they're just saying, do you want to copy those? The first pop-up is as new features are highlighted. Doesn't really affect anyone here unless you need to know what the new features are. I'm going to turn it off on mine by hitting show this at startup and then OK. The next one is the 1-minute startup movies. Unfortunately, for some of you, it's probably been since the last time you took intro class as the last time you touched Maya. So you may need a refresher in some of the tools. Here's that refresher in some of the tools. Okay. At the start of this, we'll kind of walk through these if you get stuck or miss a tool or whatever. So I'm going to turn these off, but these are just quick little videos you could watch just to kind of help refresh your brain. Okay. So now we're back in Maya. Some things you may notice from the last time you were in Maya, some of the tools have really changed. 2015 is like a huge modification to a lot of where things are, and they've added some tools and they've modified a bunch of stuff. One of the important things is under the polygon menu, they've kind of moved a lot of these tools around. So you see there's a mesh, an edit mesh, and a mesh tools box here now. So they've just kind of moved some stuff around as far as that goes. Also, I think this was in 2014, the time slider now defaults to 120 frames, where before it was set to 24 as the default. So that's good for us because we don't have to change stuff right away. Okay. So what we're going to do is we're going to set up our preferences and then we'll start animating some things. So the first one we want to do is under Create, NURBS Primitives, we're going to turn off Interactive Creation. And the same thing for Polygon. Create Polygon, Interactive Creation goes off. Okay? We don't want that to happen because it's annoying. I like to be able to just click on Create Sphere and a sphere gets created, or click on Cube and a cube gets created. So we turn it off. The next one we're going to do is when we hit Control A, so hit Control A, you'll see that the attribute editor pops up over on the right side. We want to pull that off, so just drag it off so it's floating. And then you can close it. Down here next to the key, there's a little running man that's red. We're going to click him. If I go too fast, let me know. I'll slow down. So far, there's no complaints. All right. So inside here, this is where we do all of our preferences. So we're going to set up a couple of these that we need. One thing I'm going to point out is under settings. So let's go to settings on the left side. Because we're working as new animators, and we're trying, to fit as much animation as we can into that 1 second of animation, we're going to change our time to 30 frames per second. Okay? So we're changing the time here to 30. That will give us 6 extra frames per second to play with that allows us a little bit more animation time. Okay? So if we had 24, let's say we had 6, you can't really animate a whole lot in 6 frames in a second. So adding 30, it gives us a little bit more room to work with, a little bit more stuff to play with. So we're going to set that to 30. Pay attention to the units of centimeters and our degrees are angular units. Okay, just for fun. Animation. Okay, we're going to leave the animation one alone. Whenever we set keys, just so you can see it, the default in tangent is auto, the default out tangent right now is auto. When we set keyframes, you'll see that the graph is automatically going to do that slow in, slow out process. If we didn't want that, and sometimes you don't want that, sometimes you want it to be what's called stepped, or sometimes you want it to be called linear. You could automatically change that here. Typically, people leave this alone and just set it in the graph editor. It's pretty easy to do. Also, there's a button here for weighted tangents. When we get to stuff, we could check that on too. We don't need to right now. The next area we're going to go down to, I'm just going to skip through these real quick. File and projects. There is an autosave feature. If you're worried about, I'm afraid I'm not going to save my stuff, you could turn on autosave and it'll automatically save whatever you set your settings to. Okay? It can be handy if you don't want to lose your stuff. I don't do that. Typically, I just suck it up if I lose it. Just as a reason why I don't do that, I'll show you. This is my file from the intro class. 2510, work, playing around, scenes. Here's my Lego file. This is just a Lego with some text on it, but it's duplicated a number of times. It's 176 megabytes. If I start doing an autosave to something like that, I'm saving out 200 megabytes every 10 minutes or so. So I don't want to autosave. That's why I don't have it on. Selection is fine. Snapping, sound. When we get into sound, we'll play with this. Time slider will be the next one. Playback speed. We want our playback speed set to real time. Okay? That way, as we're looking at our stuff, we see what it looks like in real time. Too often, animators will not do this, and then you animate a ball and you're like, perfect. The way it's bouncing is exactly what I want. And then you render it out, and it goes like this, or it goes super slow, okay? Because you're not seeing it in real time. By setting this, it's going to play it in real time. The downside of that is that it might skip frames, okay? So we'll do other stuff to kind of circumvent that. But if we want to play back at 30 frames a second and the computer can only calculate 3 frames a second, we'll only see 3 of those frames each second, okay? We could also do stuff like looping. You don't typically play with it too much, but looping is like when you hit the play button, it goes all the way to the end, and then it jumps around to the beginning and plays again. Sometimes you just want it to play through once, or sometimes you want it to go back and forth. We also have the height of this thing. If you have a lot of keyframes or you have a hard time seeing, and you want this height to be a bit more, you can increase that as well as the key tick size, which is this guy. Okay, that's how thick each keyframe is going to be. So if that becomes an issue, we can change stuff like that. That should be good. Undo. If you think you need more than 50 undos, set this to more than 50 undos. Okay? I set mine to 50. I'm happy with 50. That's it. Okay? So I'm just going to hit save. There we go. Okay? So we have our preferences set up. we've done that. Let's go and create a new shelf up here. We're going to go to the arrow and go to new shelf. And this shelf is going to be called animation tools. Okay. For animation tools, we want to add to this shelf things that we're going to be using for this class. All right. All of them are not specifically animation tools, but we're going to use them for the animation class. So the way we add a hotkey to our shelf is we hold down the Control and Shift buttons on our keyboard, and then we go to that tool. So we're going to hold down Control and Shift. We're going to go to Edit, Delete by Type, History. Okay, and just click and then let go. Just click off so you don't add it again. Okay, so now you should see inside your shelf there's history. If you added too many of them, you can right click and delete it. All right, so now we're going to go to Control Shift still. We're going to go to Modify and go to Center Pivot. Good? All right, cool. We're going to still hold Control Shift, and we're going to go to Modify, Freeze Transformation, and Reset Transformation. We'll get into what those things mean later. That's all I need there. Okay. Window Outliner. So add that one into it. The node editor will also add. Good so far? Okay. History, center pivot, freeze transform, reset, outliner, and node editor. Good. Window animation editor. We're going to add the graph editor and the dope sheet. That's exactly what it sounds like. And we'll also add expression editor too. Why not? Okay. So delete history, center pivot, freeze transform, reset transform, outliner, node editor, graph editor, dope sheet, and expression editor. So now what I want to do is some of these are not ones that I want to use fully, okay? I don't want to, like, if I, just so you can see what some of these will do. Here's a sphere, I've rotated it, I've moved it. It has some history on it right here. So the history button just deletes that little bit of history, okay? I move the pivot way over here, center pivot centers the pivot. If I reset my transformations, it just resets all these values to their defaults of 0 and 1 and moves the object back to where it was. If I use freeze transform, it keeps the object exactly where it is and resets all of those things. Okay? These are the first four. Outliner is where it lists all the junk we have in our scene. The node editor allows us to connect stuff together. The graph editor is where we do a lot of tweaking. The dope sheet is where we do some more tweaking. And expression editor is where we can actually write little bitty programs, little expressions for the objects. Okay? If you're familiar with After Effects, I'm sure you've written an expression at some point. But some of these we don't want it to do. For instance, I may be way over here, and then I want to do a freeze transform, but I don't want to do it on all of them. I only want to do a freeze transform on just the scale. So then I would have to go up to Modify, go to Freeze Transform, turn the translates and rotates off, and then do just scale. That's annoying to have to do. I want a button I can click, okay? So if I look at, this is going to be, as an animator, a helpful thing, this little script editor. Every single thing we do is cataloged right here, okay? So when we create a sphere or we move something, everything is listed right inside of that sheet. So if I look somewhere in here, rotate, translate marking menu, make identity. Let me do it again so I can see which one it was. There it is. So it was the make identity. So this make identity one, why ever they call it make identity, I don't know, is what's freezing the transforms. Okay. So typically there's options that we can set. So I'm going to, you don't have to do this. I'm just going to do it so we can see. Is that those are the options here that just do scale. So if we look at this, and I'm just going to copy this into Notepad so you can see it. Okay, so what this is saying is freeze a transform, whatever they call it, make identity, apply true, translate is 0, meaning don't do it to the translates, don't do it to the rotates, but do it to the scales. Okay? So what I'm going to do is I'm going to create a shelf button for that item right there that I just had. Okay? So I'm just going to set this off to the side so I can see it. And down here where it says mel, I'm going to type that in. Make identity dash apply true dash t0 dash r0 dash s1 dash n0 dash pn1. There we go. Beautiful. Okay, that's where typing comes in handy. All right, so this here should be something that will just freeze the transforms of my scale. So what I can do is I'm going to take this, I'm just going to middle drag it, and I'm going to drop it up there. It's going to say, how do you want to save this? I'm going to say mel. There we go. So now I'm going to scale it up again. Oops, and click that button. And you'll see it froze just my scales. Okay? So now I could make a button for this. There you go. That one is just rotate, just by changing the 0 for the R. And then I should be able to do that also for the translates. Oops. I accidentally started typing stuff inside there. So I'm just going to edit this, make identity. There we go. And I'll go to the other one. There we go. All right. So now I have individualized buttons for each one of these. Okay. Now this is one way to do this. This is like a long way to do this. Under help though, there's actually a mel command reference. And we'll just ask me later. And inside here you can type any command. So if I look for freeze, because I'm going for freeze transform, you'll see that nothing comes up. It's using that make identity. There it is. And now it's going to give me information for how to use make identity. Okay? So this is make identity command is a quick way to reset the selected transforms of all children down to the shape level by the identity transformation, blah, 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 blah. Okay. So all we need to do is the apply. We need that. And then we need to have that translate, rotate, and scale. And let me see what else we have here. We have the N, which is normal. We don't need that. And then we have the -pn, which is preserve normals. Okay. If we look at one of their examples, you'll see that it just says make identity -apply equals true. So they're just using it in a very simple fashion. So in this case, I'm just going to say, oops, that. So let me scale it again. Oops. Did it again, and then there we go. So we don't need that entire script of it. That entire script was basically Maya's way of writing in all that stuff. So what I want you to do is in your little mel line, you're going to just type in that. Okay. Now we have to make sure the capitals match and the spacing matches as well. And after you change the S to an R and drag it up, then change the R to a T and drag that up there. We have these 3 freeze transforms up here. We can right click on the other freeze transform and just delete it. Okay, we don't need to have all of those up there. We could do the same thing to this reset object. I'm just going to leave it there. Okay. My point in showing that was that you understand that everything that we're doing we can script. Okay. When we get into expression writing, same thing is going to happen. Everything that we're doing as far as like going into the code and figuring out what's happening there, we can do that with an expression to actually control objects and how they animate. If I had a clock and I wanted to go and tick every 30 seconds or so, or 30 frames, I could keyframe an expression to automatically do that without me having to go in there and manually keyframe that ticking happening. At one point I had this, I had a track and I had this tank and it had these missiles on it, and what I wanted to happen was I wanted this tank to randomly go to a spot on the track, rotate its missile launcher a certain degree, a random number, and then launch a missile a certain distance away. Okay? I didn't want to have to do that by myself because however many times I wanted that to happen, I wanted to be able to just say go and do it. Okay? So using this down here, using stuff that happened down here with some other expression stuff, I was able to create a script that would automatically do it. It would find a spot, randomly rotate, shoot a rocket out at a certain thing, and it would do all this other stuff too. It would actually keyframe smoke coming out of the rocket. It would keyframe this other stuff happening. It would do a whole lot of things. Another one I had, it was flippers. Basically, I wanted to start with a shape and have this other shape kind of come out of it, then another shape come out of that, and do it randomly throughout this distance. And again, using a script, it's so much easier than manually keyframing that. Okay? Especially when you have like 15 things happening every single time you do that. All right, so we're good there. Okay, so now that we have our animation tools, we're going to leave them up here. There's a video if you want to watch it, you can. And it's on Angel, I'll have to show you later. But it's a video that goes through how to create your own marking menu and add this stuff to the marking menu. Eventually we'll get into that, but right now I just don't want to get too deep into it. Okay. So that's all of our shelf stuff. Let's go up to File and go to Project Window. And in Project Window, we're going to create our project. So under the current project, we'll hit New. We'll name it Playing Around. Oh, sorry, Sarcona _ Playing Around. Add your name to all your stuff. That way you know whose it is. Also, you can move from computer to computer without having any issues. If everyone called their stuff Playing Around and I move my stuff over there and accidentally copy their stuff, it's going to hit the fan, you know. Where we're saving this, we don't want to save this to D:/Maya projects. We're going to hit the folder and we're going to save this to the D drive in our 2540 work folder that we just created. Okay, so D Sarcona 2540 work. And then just hit accept. If you don't remember from the intro class or whatever class it was you took last, Maya wants you to stay organized. That's why we create the project. When we create the project, Maya likes us. We save our stuff into the right folders. We bring in stuff from the right folders. Everything works out much better. Okay? So now what we're going to do is go to File and Save Our Preferences. Somewhere in here, there it is. Okay? That actually writes out all of our preferences to the D drive, to that Maya 2015 folder. Everyone's good so far? Preferences are saved? All right. So what we're going to do now is we're going to have a little race. So you're going to create a sphere. Create, I don't care, NURBS or polygons. And we're just going to move it to a, oops, I'm rotated around, -12 in the Z direction. Okay, so create a polysphere, a NURB sphere, move it to -12 in the Z direction. Also move it to 1 in the Y direction. I want the object sitting on the grid. I don't want it cut halfway through the grid. Typically when you animate, you should consider that grid to be the ground. So that way you're animating everything to interact with the ground. Okay? Good so far? Okay, didn't lose anyone on that one. Alright, so what we're going to do is we're going to set a key. If you look at mine, I'm not sure if yours is the same as mine, but my first frame over here says 1, 1.25. Does everyone else say 1 and 1.25? Okay. Change the 1.25 to 1. All right. These down here, so we can go over them, this is your time slider. This is the frames that we are currently looking at. This little ticker over here is what frame we're currently on. You'll see that I'm still on frame 1.25, okay? So I'm going to click on my rewind button over here, the go back to the beginning of the play range button, to get back all the way to frame 1. All right. This next area, this is how many frames I start with, or what frame is my starting frame. This is what is my ending frame. The inner two are what is my work area. So imagine I have 1,000 frames. I'm working on just those middle 100. I can set my work area to just focus on those middle 100 without seeing all the stuff on either side. A tip is if you set the this one here to make it bigger, then both of these numbers get bigger. If you set this one here to make it smaller, then both get smaller. For instance, you don't have to do this, but if I wanted 500 frames, you can see how both numbers change to 500. If I went back to the defaults, 120 I think it was, and 210 or something, and I set this one to 500, that only sets how many frames I have. It doesn't set my work area, and then I can set my work area. Right. So just a little tip. 210 and 120. All right. All right. So we're going to set a key. So we're on frame 1. We have the ball selected. Frame 1, good, everything's selected. We're going to go to Translate Z, and we're going to right-click right on the word Translate Z in the channel box and say Key Selected. Okay, so I've right-clicked on the word Translate Z, and I'm keying the selected attribute. That makes this little thing salmon colored. I think that's the right color, yeah. Okay. Now there is a difference if we right-click. Oops. Delete. Okay. If I right-click here, it's not going to do anything until it highlights it, and then I right-click again. I always right-click right on the word, and that way everything is happier. Okay. I can also click and drag and right-click and key several things at once. All right. So we're keying Translate Z. We're going to go up to 60. So over here, this is, like I said, what frame we're at. We're at frame 1. We want to go to frame 60, so we can just type it in. And we're going to set this to be positive 12. And then right-click, set another key. After Effects, we set one keyframe, and After Effects does the rest for us. It has what's called auto key, meaning that once we've established we're setting keyframes on one attribute, it automatically sets the rest of them. Maya has that ability, but as a beginner, it's too easy to screw it up. I was going to say something else, but I figured. Okay? So we don't want to have auto key on. We can have it on. If you accidentally turn it on, it's this little guy right here. Okay? That little key right there means it's auto key. Avoid using auto key right now. When you get more comfortable, then you can start doing it. And the reason we don't do it, I'm going to show you, is that sometimes we forget about it and we just start moving stuff around. And every time I move this thing, it's setting a keyframe for it. And so now I have this really, not smooth animation of this thing moving around. Go back to that and reset this, reset that, and reset this. That. Okay. All right, so now we have our animation 1 to 60. Let's set our work area just to go to 60. Okay, so we just set the inner one here to 60. And then we're going to hit the play button. Whee! So now that we have this thing moving across, you can see I'm sure yours is doing the same thing as mine. We have that slow start, and we have that accelerated middle, and we have that slow end. Okay, so we're going to hit stop. We're going to rewind it to the beginning. Just so you can see what the other buttons are that are up here. This guy here is rewind all the way to the beginning. This one is go back one frame. This one with the red line with the red tick in it means go back one keyframe. when you're dealing with an animation of a character, sometimes your 7,000 keyframes are in this small area, so you want to jump right back to the last keyframe, or you're jumping between poses. This is play backwards. This is play forward, and then these do the opposite but in the other direction. Okay. For some odd reason, play backwards actually will go super slow sometimes, like incredibly slow, like slower than doing this. Like me scrubbing it backwards is slower. I don't know. It just does. Okay. So what we want to do now is, it's not really a race if we only have one ball here. So we want to duplicate that ball. If I just hit Control D, it's going to duplicate the ball, but it doesn't duplicate any of the animation to it. So we don't want to do that. Okay. We're going to make sure we're on frame 1. We're going to go to Edit with the ball selected and go to Duplicate Special. Okay. Duplicate Special allows us, and the option box. If you didn't go to the option box, hit undo and then go to the option box. Duplicate Special allows us to do stuff like duplicating the input graph. Okay, basically everything that's connected to this sphere, duplicate all that stuff too. Okay, so that's what we're going to do. We're going to hit Duplicate Special with the input graph selected, and now we have two spheres. Okay, right now we've duplicated them. There's two spheres there, but they're right on top of each other. So we need to just take the red arrow and just scoot this sphere over. Okay, so I just moved that sphere over after we duplicated it. Stop. And we're going to go to our graph editor. So in our shelf, we have the GE, which is Graph Editor. We're going to click that. And if you have something selected, you might see something inside the graph. If you don't have anything selected, you won't see anything in the graph. Okay? The graph will load based on what you have selected. So if I have all of them selected, it's going to show me all 5 spheres and all of their keyframes. Okay? Right now, because they're all doing the same animation, all those graphs are the same. So we're going to pick on any one of these. I don't care which one. And then we're going to grab the graph and then hit F to frame it. Okay? So grab the ball, grab the graph, and hit F to frame it so we can see full screen. There's our graph. Okay? Now if our window here is differently sized, like so, you'll see that it doesn't really look like a whole lot of movement going on right there. Or if it's like this, you might see, wow, that's a lot of movement in that ball. Okay? Just be aware that it all depends on what your scale is of that. Also within here, sometimes we'll have something like rotate. Rotate is not something where we go from like 0 to 1. It's usually we go from 0 to 1400. Okay? So when we're looking at graphs of scale and rotate and translate together, sometimes it can get very confusing because this is what we see. Okay? This graph doesn't look like it's moving at all. It looks perfectly straight. It's just because what I've done is just zoomed way out and I'm just seeing that flattened. So it's always good to pick on it and hit F. Okay. So now up here at the top of this thing, these are all the different default tangent types that are out there. Okay? So we're just going to start with one of these and just click on one of them. Then go to the next ball, the next graph, click on the next one. The next ball, the next graph, click on the next one. The next ball, the next graph, click on that one. Okay? And there'll be an extra one there. I don't care about the extra one. That's going to be the same as the other ones. Now it looks like one of the balls never moves. There's a flicker, but it doesn't look like that last ball ever really moves, right? He is moving. If we go to frame 60 his frame, his keyframe is here, is there. If we go to frame 1, his other keyframe is here. Okay? That's what's called a stepped keyframe. And of all of the keyframes, that's typically the most drastic one because it literally jumps from one value to another value over the course of a frame. Okay? It's handy for stuff like particles. If we have 7,000 particles being emitted and then we just want to shut off, we can go from 7,000 to 0 over 2 frames, and that would do the same thing. Or we can say here it's 7,000, here it's 0, and it automatically just clicks off. Okay? Or we have a light. We want the intensity of that light just to cut off at a certain point. We can do that as well, just by using stepped keyframes. Sometimes an animator will actually watch all their poses with stepped keyframes. That way they can just see pose to pose to pose. When we watched Horton, that top right one was all stepped keyframes. So they grab all their keyframes, all 1,000 keyframes, however many they have, and make them all stepped. That way it just jumps, and they can just see those poses. Okay. If we look at a couple of these other ones that are in here, you'll see these 3 are pretty much the same. Okay. This one is doing something a little bit different. Let me see which graph that one is. I think that's the smooth one, yes. Okay. So this one here is the slow in, slow out. The other one, these guys, those are my linear ones. Those are the ones that are just going from keyframe to keyframe. So now your question probably is, okay, well, why do we have these 3? We clicked on different buttons up here, but they're doing all the same thing. Some of these rely on having more than 2 keyframes set, okay, and how it interprets from one to the other. You'll start to play with those, and eventually what's going to happen is you're going to use those as a starting point. Typically, I'll go, either plateau, which is my new favorite one, or I'll go linear, and then after that, I just do all the tweaking manually, okay? Just like Illustrator and Photoshop with the pen tool, we can actually grab these handlebars and move them all manually. So now what this is going to do, there we go, is it's going to start off super quick. That's what that front part's going to do. It's going to go zoom, and that's going to go super slow. Okay, so let's watch number 3 and see if that's what number 3 does. You can see it starts off super quick ahead of everyone else, and then it goes super slow at the end. Okay, we can even do the opposite. I'll make this one plateaued so it's flat at the beginning, and then this one I'll just adjust like that. Come on. All right, let me just free this one. It doesn't want to be pulled down anymore. There we go. So now you see slow start at the beginning, and it picks up speed at the end. I just spit. So we want to actually be able to play with these and understand how to move these and how to get them to do what we need them to do. These black areas in the dope sheet are the keyframes that we've set. Now it's very easy when we're in the graph editor. We can grab a keyframe and we can scoot it around, but we can also accidentally change its value, which would really mess it up. Okay, especially when you get into this one here. These positions of this ball are critical. If we modify those positions, it's not going to look right. So the dope sheet allows us to modify keyframes just in time. So what we're going to do is we have the first ball selected. We're going to marquee this keyframe. I marquee this far right side, and then just middle mouse button drag it. Okay, and that allows me to adjust where that keyframe is in time. I'm not adjusting the value, just the time. And then I'll grab the next ball, and I'll marquee that one and adjust that one too. I'll even adjust the middle one. I'll even adjust the first one and just pull it over towards the right. That way we're still in the positive time. No one's cheating. All right, so now we have an actual little bit of a race where there is actually 1 or 2 of these that get there at about the same time, or there's probably one that actually is the winner, just by setting a couple keyframes, tweaking some of the graphs, And then going through and editing some of the dope sheet stuff. The dope sheet is also great for some of your characters or some of your objects you animate might have literally like 100 keyframes for one frame. Okay, so you might have, like, if you're doing a character, the wrist, the fingers, the elbow, the shoulder, the collarbone, same thing on the other side, spine, head, everything. So you might have 100 keyframes. This allows you to take that 100 keyframes and just scoot it over. If you do a pose, like your character's standing however, and you want to take that pose and move it over a frame or two, that's a great way to do it. Okay? So there's our race. It's wonderful. It's beautiful. This one actually wins. I think he wins. Yes, he wins. Okay. And this guy is transports. Okay. So wonderful, beautiful stuff. All right. So let's save our scene here. And just call it race. I don't care what, just so we have it for reference if you need it later. Okay. The other thing that we can do, we've played with the graph editor just a tiny bit. We played with the dope sheet a tiny bit. We can also manipulate stuff down here. We don't need to go into it, today. As we start doing some of these assignments, our first one is going to be this little stick thing that we do, the bouncing ball and the ball on track. We'll get into using a lot of these things. But there's even tools down here where I can marquee these and adjust what these look like. So what I've done is I've taken my 3 keyframes and I've squished them together. Okay? So now this guy in the end, he'll actually win. Boop. He gets there right at frame 9. Okay? Because that animation has just been compressed. If I do it to one of these, it's a little bit more impressive. There you go. Okay? Also, in our timeline, if you left click and drag, you can do this. Go ahead and left click and drag in your timeline. This is called scrubbing. Okay, it's just going back and forth, seeing what it looks like. Okay, now use the middle mouse button and click and drag. Notice how the time does not update. This is incredibly helpful if we have a pose that we want to capture from the beginning and paste on the end. Okay, if I'm at this frame here and I say, you know what, let me grab this guy. Okay. I really like where this ball is positioned here, but I want that to be the same spot way back here. What I can do is middle click way back there and reset a key for it. And now that object has a keyframe back here. It stays there, and then it goes again. Okay? So sometimes we'll use the middle mouse, sometimes we'll use the left mouse. If you shift and use the left or middle mouse button, that's what I was using to get that red in there. And then we have arrows in the middle. We have arrows at the end. You can't see the one here, but there's one there. And that allows us to scale these keyframes together or to move them around as a group. If we had a character, or we had a ball bouncing. Here's the ball bouncing perfectly right here. We can marquee that area, copy the area, paste it here, paste it here, paste it there. We can actually create clips. If you have a person walking, we can create one cycle of the person walking and then duplicate that cycle so they walk however often or however fast or anything we need them to walk. Okay, so it's really cool stuff. I'm going to show this stuff real quick too, just so you can see some examples of different things that you might have to animate at some point. One of my students, shortly after they graduated from Macomb, their first job was to animate a convertible top opening up and closing. Now, it doesn't sound very difficult, but they had to animate all the mechanics involved in that. And if you've ever seen the mechanics of a convertible top, you will now. Bing sucks for this one, apparently. Google always pulled it up. Oh, the mechanism. There we go. There's a whole bunch of stuff that happens inside here that makes it work. It's not just like, here's my convertible top and it just rolls over like that. There's actually stuff that bends and rotates and whatever else to get it there. So this is complex stuff explained in simple animations. So this is weird probably, but I've always wondered how a sewing machine works. So here's how a sewing machine works. So the needle goes in, and this little hook grabs onto the thread and puts it, through that, and that's how the thread stays together. This is something, as an animator, you might actually have to create a 3D model that would show that and would work. Think of like a fishing rod. How would you animate string on a fishing rod going through the loops, going down, and then someone like winding it up, right? All that thread, all that geometry kind of going back in the loop, it's a tricky thing. I think it's a video. This one is really cool. You can see that all these things are doing, this thing's going here, this thing's going here, back and forth, this is going here, but this whole thing is spinning around because of how those two things are moving back and forth. That's crazy. That's all it's doing, is those two things are moving, and that's it. It's just rotating that thing around. And there's where something I guess you could do that with. Here's a radial engine, and here's how the radial engine works. You can see there's just something in the middle that's spinning, and all these pistons are just going in and out the way that they would be going. If you work at places like Quintech, Quintech does a lot of automotive stuff, and they do a lot of stuff like, how does this stuff work? You need to know how this stuff works, okay? This one is pretty cool also. This little thing spins and ticks this thing over. So if you have a gear controlling this thing, and the gear for every 6 times it spins around needs to spin this other thing, look at that. It's awesome. There's a little animation of it. All right, that's one. And then this other one is 20 animated GIFs that explain how things work. There's a zipper, how a zipper works. There it goes. This is unrolling a circle's circumference. So if you need to know how to unroll a circle's circumference, there it is. Okay. This is incredibly helpful for, let's say you're rigging a car, you're animating a car. That's the roundest thing I have right here. As the car is moving down the street, what you don't want to have is you animate the car going this way, and then you come back and animate the tires. What is great about it is if you can tie those things together and say, as the car is moving this way, I want this to rotate a certain amount, okay? So using something like this, you could actually build a little expression, a little formula that would tie those things together. If the car moves, let's just pretend this, in this example, 3 1/8, okay? If the car moves 3 1/8 units, then the wheel's going to spin around 360 degrees, okay? So we can tie those things in together so that the animator doesn't have to think about it. How a pill press works, it's kind of neat. Not as impressive as the other ones. Locomotive, that's kind of cool too. Very trippy. This is in chess how a knight visits every square once. How a caliper works. Some of these are weird. This one is pretty cool. This thing's spinning, and this thing is connected with these spheres, and it's just like how these two things are spinning together is really awesome. You don't have to create these things in a dynamically connected way or anything like that. They literally could be this object spinning this way and this object spinning that way, and these spheres are just moving from inside to out. You just have to understand how they work in order to kind of show them. How circle strapping works, in case you need to know. This one wasn't as good as the other one. How the Pythagorean theorem works. That's a pretty interesting one if you're into math like I am. There's a radial engine again. There's that thing again. Spinning dancer illusion. Has anyone seen this before? Not seen it before? Has anyone not seen it? Everyone's seen it. A couple? Which way is she spinning? Clockwise or counterclockwise? Same? It depends on how you look at it. You can actually change the way she spins. There was a Brain Games. I've ever watched Brain Games. It's a cool show. But they go over all this kind of stuff where they show this girl and then they switch it. And all they're doing is just showing you an image of the girl spinning the correct way or however she actually was, and then they do it again. It's crazy. There you go. That one's just kind of neat. There you go. How a Stirling engine works. How to draw a yin yang with circles. That's kind of stupid. That one's kind of neat. How a sewing machine works we've seen, and then how the sum and planning gear work. And then the New York Times crossword before the 1996 election worked. This one was just funny. Depending on who won the 1996 election, the New York Times had 2 crossword puzzles exactly the same, except for these 7 letters here that would alternate, would be able to switch. So depending on who won the election, they could just switch out the name. That was funny. All right, so as we start doing more animation stuff, we'll get more and more into this, okay? I don't want to fry your brains too much on the first official day. We're going to save our preferences and back our stuff up, and then I'm going to let you guys go. Wednesday is our next class. Remember, there's no class on Monday, okay? So make sure your stuff is saved and close Maya, and then we're going to back up our preferences and back up our scenes. Okay, so once it's saved, close Maya down, and then we're going to go to the D drive. And then in the D drive, we're going to the Maya folder, where we're going to right-click and cut our preferences out of there. Okay, get in the habit of cutting your preferences out of that Maya folder. That way nobody can accidentally start writing information to your folder. Okay, if you had this happen last semester or whenever it was you took Maya the first time, sometimes people just open Maya, start working, start rendering stuff out, and pretty soon you have gigs and gigs of data in your folders you don't need. All right, so we're cutting this. We're going to go back to the D drive, back to our folder that says F14, back to our 2540, and we're just going to paste it inside there. If you're in multiple classes of mine, I recommend you can use the same preferences, that's fine, but just be aware that in some of the classes we're using 24 frames per second, and in this class only we're using 30. Okay, so like in the modeling class we're using 24. Okay, and that's really for rendering purposes. That way we only have to render out 24 frames as opposed to 30 in those. Okay, so once you have your preferences copied here, then we're just going to go back to the D drive and we're going to right click on your name folder and copy it. And then in the left you should see student, Xall student. I'm going to the 2540 folder in student, and I'm just going to paste my stuff right there. Okay, I'm not actually going to paste mine because it's 18 gigs.